Okay, group, we are on our 4.2 notes, which is reflections. And reflections are a type of transformation where our geometric figure is flipped over some sort of line, and we'll call it the line of reflection. Super fun. Okay, super fun. So this can look like so many different things. It can be flipped over the x-axis. It can be flipped over like a y equals line or an x equals line. It can even be flipped over the y-axis or the y equals x line. So we're going to talk about all those different examples here and example number 1. So if we look here at flipping this guy over the x-axis, right? Our x-axis is right here. Okay, here's our x-axis. And so you can simply count your points and flip them over. Okay, let's do that to start. So if I look at point K, it is 1 up, so I'm going to go 1 down because I'm going to flip it over the x-axis. So there's my new K point. Okay, now I want to talk specifically about that actual point. So the point was 4, 1. And now it is 4, negative 1. So what happened is my y changed. It changed to a negative. I just flipped the sign on that. Let's go ahead and try L. L is 3 up, so I'm going to go 3 down. So there's my new L. Okay, so that L point was 5, 3. And I bet you can guess what our new one is. 5, negative 3. Right? So we just flip the sign on our y. So that's an easy way to remember it. Okay, same thing with N. It was 3 up, so we're going to go 3 down. And M is 1, 2, 3, 4, 5 up, so we're going to go 5 down. And we'll connect our points. And there's our reflection over the x-axis. So you can do it by knowing the rule of keep x, change y for these guys, or you can simply count. All right, our next one is a reflection over y equals 1. And so here we don't have an axis. We need to draw that line. So if we find our y equals 1 line, y equals 1 is right here. So I'm going to draw a line there. Okay, and I'm going to reflect my figure over that line. So if I do the same counting method, I take T, it's up 1, I'm going to go down 1. U is up 3, I'm going to go down 3. Oops. S is up 1, so I'm going to go down 1. And V is up 3, so I'm going to go down 3. And if you notice, I'm always counting from my line of reflection. So there we go. We have a reflected figure over the line y equals 1. It's very similar for the line of x equals 2. So x equals 2 is our vertical line here at -2 crosses the x-axis. Okay, now this is kind of interesting because we have 2 of these points that are on that line. If they are 0 distance from the line, they're actually just going to stay there, which is really nice. So now we have our new B and C. Okay, D is 1, 2, 3 from the line. So I'm going to go the other direction. 1, 2, 3. And A is 2, so I'm going to go 2 the other direction. So we reflected over the line x equals -2. Okay, so now we have over the line y equals x. And this one can be a little bit trickier. The line y equals x goes directly through the origin. Looks like that. So when x is 1, y is 1, x is 2, y is 2, it kind of goes in both directions there. Okay, so this one can be a little tough. Okay, so what we do is we kind of look at our diagonal here. So if I was to draw a line, if I was to draw a line from T to my my line here, it looks like it wasn't a perfect there, but it looks like it's about 1, 2.5 diagonals. So I'm going to do that same thing the other direction. I'm going to go a half and then 1, 2, and it looks like it should be about 2, -3. Okay, so let's talk about this point T really fast. The point T was originally at -3, 2. If you look at that point, it was at -3, 2. Our new T is now at 2, -3. So if you look here, what actually happened is we just flipped the X and Y values. That's our rule when we're flipping over the Y equals X line. So you don't have to count these diagonals every single time. You can actually do it by using the rule of flipping X and Y. So let's try U. U is the point -2, 4. So when we reflect U over the Y equals X line, it should be 4, -2. So if I look here, it's about 1, 2, 3 diagonals away. So if I go 1, 2, 3 diagonals away, I end up at 4, -2. So that does, you don't always have to count it based on the diagonals, but it's a good way to check your work. Forgot to label my T and my U, so I'll go ahead and label those. Let's go ahead and do S. S is at -5, 2. So our new S should be at 2, -5. V is at -4, 4. So our new V should be at 4, -4. So now if I erase my diagonal lines so that you can clearly see what's going on here. Right now you can see how I took this figure and I flipped it over that Y equals X line. So I think it's a lot easier to do it via the points. Let's try it on F. So on F, here we have point F is at -1, 2. So that means our new point should be 2, -1. Guess I could draw my Y equals X line. I forgot to do that. Okay, E is at 4, 1. So our new E should be at 1, 4. And then D is at -1, -3. So our new D is at -3, -1. So you can see how that reflected over the Y equals X line.